So you've just seen a remarkable demonstration from Bill Yosses, who showed you how to start with seemingly simple ingredients, sugar, water, and a little bit of glucose, and he was able to transform it with proper skill into a candy apple. That is a shell of candy, of sugar glass, that actually was shaped to be perfectly like an apple. So you saw from the video of Bill how much care and skill was required to make this happen. And in every one of the steps that he went through and told you about, there was an enormous amount of science that was behind it. And what I now want to do is to try to go through and step through the important elements, the scientific elements of the recipe, and try to argue and explain to you how it fits into the learning goals of this week in the class. So in order to do this, there are three important facts about sugar, sugar water, heated sugar water that I want to emphasize to you that are going to come up when we start to think through the recipe that Bill made. So the first is that, of course, sugar water, the sugar that you put in sugar water is sucrose, and sucrose is a disaccharide which is made out of glucose and fructose. And so sucrose is bigger than both glucose and sucrose. Now, and so you'll remember glucose, Bill also added glucose to the mixture. So one of the things that we're going to want to think about is how are we supposed to think about sucrose and glucose as being added, and what different roles are they playing within the recipe? So that's the first important fact. So the second important fact is something that we've mentioned in this class before, which is the idea that the solubility of sugar, that is sucrose in water, increases dramatically as a function of temperature. So whereas you can dissolve approximately 2 grams of sugar for every gram of water at room temperature, when you go up to 100 degrees Celsius, you can dissolve about 4 grams for every gram, and the solubility goes up more and more as you increase the temperature. So the hotter something is, the hotter the liquid is, the more sugar can be dissolved in it. This is the second important fact that plays an important role in this recipe. And finally, the third important fact, which we've also already mentioned, is that the boiling point of the mixture, of the sugar-water mixture, depends critically on the mass fraction of sugar. So that the more mass, the higher the percentage of the mixture is sugar, the higher the boiling point is. It goes up from 100 degrees Celsius, the boiling point of the mixture when there's no sugar, that's just the boiling point of water, to around 150 or 160 degrees Celsius once the mixture becomes almost entirely sugar. And you might recall we've mentioned before, and the way that you should think about this curve, that is the boiling point as a function of the sugar concentration, is that this is really dialing in the mass fraction of sugar. So that if you were to heat the mixture up to 110 degrees Celsius, then that corresponds to a mass fraction of sugar of about 60, 70%, somewhere in that range. If you heat it up to 140 degrees Celsius, then that corresponds to a mass fraction which is in the range of 80 to 90% of sugar. So what you're really doing when you use a candy thermometer, and you'll remember that in Bill's cooking, he had this candy thermometer in the sugar water, and he was very, very careful to tune the temperature. He said, the temperature needs to be between 150 and 152 degrees Celsius. That's what he told you in order to make the glass, and that you can't go any lower. If you go lower, it doesn't work. If you go higher, it doesn't work, and he talked about that. The way to think about it, and the way that I'm going to try to get you to think about it, is when you're between this very narrow range of temperatures, that's actually very, very carefully controlling the water content of the sugar mixture that is used to make the candy glass. And that's actually, it's the very sharp nature, the very sharp dependence of the boiling point on the mass fraction of sugar that basically gives rise to the need for this exquisite temperature control when you make candy. Okay, so let me just say a couple of words about candy making, just as context. This is something that Bill mentioned and that you should all read in Harold McGee's textbook. That's explained very well there, but is important to know as context. So on a candy thermometer, there are words that go with temperature ranges. There is the thread, soft ball, hard ball, firm ball, soft crack, hard crack. And Bill told us that actually that the range that he was trying to work in was the hard crack range, which, as I said, in his case was between 150 and 152 degrees Celsius. On typical candy thermometers, the range of hard crack is slightly larger than that. And what I'd like to do is explain for a minute where these words come from and what they mean, because that really, if you start to think about it, is an important part of the recipe. So remember what Bill did, and he did this in his demo initially before he actually started molding the sugar glass. What he did was he took a spoonful of the sugar water out of the pan, which was between 150 and 152 degrees, and he then poured it on the counter, and it solidified. And he showed that it was like glass. It was hard crack stage. It was like crackling. And so these words, the crackling, basically refers to the fact that if you heat up sugar water to that temperature and you then quench it, quench is a scientific word that means cool rapidly to a cooler temperature, then what the mixture feels like is something which is hard crack, soft crack, hard ball, soft ball. The words actually are a measure of how it feels when you basically do this procedure. So, and that's really at the essence of what's happening. I mean, when Bill took this sugar, when he took the sugar water and he poured it on the pan, what he was effectively doing was taking a mixture that started out, if we think about the phase diagram of the sugar, that is, if we plot again the solubility as a function of temperature, he was starting out at 150 degrees Celsius, and he then quenched it. That is, he rapidly cooled it to a much lower temperature. And of course, and I don't know, I mean, you remember he poured it on the mat on the table, and I don't know what the temperature of the table was, but it's certainly much less than 150 degrees. That is the temperature that he cooled it to. And so when he cooled it rapidly to that temperature, the sugar content that was in the mixture was now much more than this plot of the solubility as a function of temperature gives you. You're at a much higher concentration than you're supposed to be able to have, given that you've now cooled it to that temperature. So the question for you is, well, what happens, right? That is, if you take this sugar-water mixture, which you've initially prepared by heating up to a very high temperature, and you then rapidly cool it, what happens to the material? Well, what happens is that the sugar tries to form crystals. That's what it wants to do, right? If you're sitting at a temperature like, say 80 degrees Celsius, the solubility of sugar and water is much less at 80 degrees than 150 degrees. So if you ramp from 150 to 80, you've got too much sugar. And the excess sugar, scientists call it supersaturated, that sugar tries to form crystals, which will form, and that you will get these crystals in the mixture that will form until the residual amount of sugar that's left dissolved in the liquid corresponds to the amount that there should be according to this plot. That's what's going to happen. So when you quench, and when Bill basically did this, if you now imagine in your mind him pouring this sugar out and carefully trying to cool it and to basically play with it with his hands, what was happening when he was doing this is that crystals were forming. And that those crystals, of course, were making the material, since they were all sort of jamming into each other, they were making it much more, scientists say, viscous than they were when they were in the pool. Now, that leads me to tell you the following thing. So this discussion that I'm about to go into is really in the context of the current week of the class, which is a week, as you all know, about elasticity. In a few weeks, we will talk about viscosity, and I'm going to go a little bit ahead of where we were and give you a little bit of an introduction to viscosity as I'm going through this, but I'm going to try to basically just emphasize the parts of this which refer to the present week about elasticity. The two are really connected. Viscosity is about pouring things, and elasticity is about squishing things. That's basically what we've told you. And you see in the sugar water, you have both pouring, that is, you have a liquid, which then becomes a solid, right? And it's sort of got an elastic modulus, which is what we've talked about. So the discussion I'm about to go through, I'm going to sometimes use words that are going to be more appropriate in the viscosity week. And that's okay. We're just getting ahead of ourselves a little. We'll come back to some of the ideas then.